Welcome back, everybody, and thanks for stopping by. The next topic we're going to be diving into is going to be the dynamic trunking protocol and the trunk allowed lists. Now, these particular topics that we're going to be diving into are specific to trunking and not necessarily security features per se, where they don't actually, it's more of an optimization, but there is a security plus a resource utilization perspective to them that I think are both important. Now, DTP, or Dynamic Trunking Protocol, that allows you to negotiate the mode, the operational mode of a port, whether it's trunking or access and stuff like that. And you might say, well, how does it know how to negotiate whether it's a trunk or an access port? And the simple answer is, if BPDUs are received on the port, then it knows there's a switch attached. So that's how it's going to negotiate that. And there's 802.1q encapsulation, there's ISL encapsulation. That's how it's going to know which particular trunking protocol, or I should say encapsulation mechanism to use. So in that particular case, that's going to be how that comes into play. Now, the trunk allowed list is a little bit different, which takes place after negotiation happens and the mode has been decided, the encapsulation mechanism has been determined, all that type of stuff. What's going to end up happening after that is going to be the aspect of, now that I have, let's say for instance, switch 1 and switch 7, I've already got DTP enabled. I'll just show you a couple of variations of how that comes into play. I didn't see a whole lot of value in showing you that because there's a lot of other stuff that's out there. The trunk allowed list is a little bit different, but this is going to restrict what traffic is going to be allowed to traverse the trunk. So DTP will negotiate the trunk and all that type of stuff, but trunk allowed lists will determine if I have, let's say, 100 VLANs, do I really want every VLAN to be able to propagate MAC addresses across the trunk link? And that's really ultimately what's happening, because if I'm here, if I put server 2 on gig 0/2 into VLAN 10, then that means that there's going to be able to communicate between at layer 2 between these switches, right? But in a situation where I need to allow server 2 to be able to talk to ASAP1, but server 2 is in VLAN 30, but I don't want server 2 to be able to talk, I don't want any MAC addresses from VLAN 10 to be able to propagate. So let's take a look at that real quick. Let's go to switch 1 real quick. We do a show VLAN brief. I have VLAN 10 created. I type in show interface trunk, and I look and I have a bunch of VLANs that I can propagate, right? VLANs 1, 10 through 12, 20, and 30. Well, if I look at switch 7, that's physically connected to it, I do a show interface trunk. I also have VLANs 10, 20, and 30. Well, I don't have 11 and 12 because VTP is not working. But if I do a show MAC address table dynamic, I have MAC addresses for VLAN 1, 10, and 30. But if I look at show VLAN brief to see what ports are allocated, gig 0/2, which attaches to server 2, connects to VLAN 30. So that means that if server 2 wants to talk to ASAP1, it must hit server switch 7, go across the link to switch 1, and then up to ASAP1 over the trunk link. Everybody understands that. So, and that's basically how this flow works, but I don't want switch 7 to have a bunch of VLAN 10 traffic on it if there's no devices in VLAN 10. Because right now I don't have any devices that would need to talk via layer 2 between switch 7 and switch 1 in VLAN 10. Does that make sense? So what I'm going to do on switch 1 and on switch 7, on those connections, I'll type in interface gig 1/1. I'll type in here switch port trunk, and I'll use the allowed VLAN characteristics when interface is in trunking mode. What this will allow me to do is determine what VLANs will be able to cross the trunk link. Okay? So I can come in here and I can type in, I can remove a VLAN, I can add a VLAN, all that type of stuff is optional. So I'm going to type in, I'm going to say VLAN, the very top one, which is word, which is VLAN IDs of the allowed VLANs when this port is in trunking mode. I'm going to type in 30. And I could hit the enter key. Now that's only going to allow do show interface trunk VLAN 30 to cross that particular trunk. I go to switch 7 and I do a show MAC address table dynamic, and after a period of time, not long, VLAN 10 traffic will eventually age out. Now if we do a show run interface gig 0/1, this side is not configured for the trunk allowed list. So I type in interface gig 0/1, I type in switch port trunk allowed VLAN 30. Okay, now that I've done that, I jump back out of global config, I do a show MAC address table dynamic, and what don't I see anymore? I don't see VLAN 10. Now you might say, well, how applicable is this to production? I'll give you a very practical example of something that I had to deal with in a production network not too long ago. It was a customer that I did some work for, third-party consulting, and basically what ended up happening was they had a very large stretched network. So think of it like a data center, but they weren't using data center switches. They were using Catalyst 6500s and a bunch of Catalyst access switches, 2960s and 3560s and 3850s, your lower end Catalyst switches. I was not a big proponent of that particular model of switch or those particular models of switches. I was trying very diligently to try to get them away from that design because it doesn't scale well. You eventually will run into a limit, and let me explain why this comes into play. So if we have a situation like this where we have, let's assume that these are my backbone or my core devices, and then I have a bunch of access layer. So I'll draw, a few access layer devices out, just because some will be a little bit bigger than others, because I'm trying to show you scale here versus not just how this functions. Now what happens is every one of these devices connects back to the core, right? So what ends up happening, and these are all fiber optic connections in this particular example, and I had a chat with the engineering team about this particular design, and they were aware of the problem. And being aware, there's only so much you can do as an engineer, and sometimes you lose the fight. But the problem that we had is, or I should say, the problem that the customer had was they had a lot of VLANs, several hundred deployed. And I'm not going to get into how they were doing a bunch of different stuff on the back end. That's irrelevant at this point. Oh, and by the way, these switches here are interconnected with each other as well. So what's happening is these switches right here, the access layer switches, are dual uplink connected to the upstream switch, or switches. So what ended up happening was, in a situation where you have, let's say, 10 VLANs, that's not so bad, right? You have 10 VLANs, and let's say you have 2 nodes per VLAN, which means you have a total of 20 MACs. So we have MAC, let's say you have 20 MACs. So what's going to end up happening is those 20 MACs are going to be propagated this way and propagated this way, right? Ethernet is a flood and learn type of technology. So we take that, we learn those 20 MACs here, 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 and here, and here, and here. Now on these 6509s, that's not so bad, right? Because they've got a larger cam table, more RAM, more CPU, the ability to handle those bigger cam tables. In a situation like this, we ran into the problem where, guess what? Some of these switches here could only handle, they could handle 1,000 VLANs, right? But they could only handle 1,000 MAC addresses. So you might say, well, that's not that bad. Well, in this case here, it was. There were approximately 6 core devices, so 6 6500s, and there were around 100 access layer switches. So when you take that into consideration, now this was split up into 3 separate data centers. You had DC1, DC2, and DC3. And what ended up happening was they had all this connectivity. So DC1 had about 30, I'm sorry, no, it was more like, I think it was like 20 access layer switches. And in DC, this is DC1. In DC2, there were about 60. And in DC3, there were about 20. So it's about 100 across the board. Now, what the problem with this design is you get to a certain point and you've got, it wasn't just a single 48 port switch that was connected in here. Oftentimes it was 2 or 3 or 4 3750s in a stack. So that's 4, I'm sorry, well, we'll go with 3. 3 by 48 ports. Now, you might say, well, that's 96, that's 100 and, let's say 150 ports. It's like 100, let's say 140 ports. 140 ports. So that's 140 MAC addresses total. And really, that's not that many. Now, that 140 would exist here, 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 and here per switch. So that's 140 on this particular stack and every other switch. So if you have, think of 20 times, now it wasn't three stacks, a 3 switch stack per access switch. Sometimes it was a single switch. But still, let's say 48 ports. So let's take the average. Let's say that for out of 20, there were 3 switches. We'll split that in half for everything. So 10 were 3 switches per stack. So that means there's 30 switches out of 10, and the other were 10. So that's 40 switches at a minimum of 48 ports. So when you start to count up the ports, that's not, the numbers start to grow. But that's not the actual final number either. We had plenty of customers that were plugging into these nodes that were running virtual environments. What does that mean? That means that for one port is usually 1 MAC, right? Well, that's true if you're connecting a single server with a single NIC to a single port. But if you're connecting an ESXi server with potentially 20 VMs running, that's 20 MACs learned on one port. So then, as you can see, it quickly can escalate. There were switches that had 1,500 MAC addresses sitting in their CAM table. That switch is not acting like a switch, it's acting like a hub. I had numerous conversations with this customer saying, okay, we need to do something about this. The simplest solution that I came up with was trunk allowed list. Let's go ahead and put a trunk allowed list here on the core facing side. So on this side here, put it on the core facing side down towards the access. Don't put anything on the access side. And only in the trunk allowed list, only put in the trunk allowed list going down to the access whatever VLANs were actually in use on that switch. Makes sense, right? Because then if you've got, let's say you've got 10 VLANs, you allow those 10 VLANs in the trunk allowed list. So your command would be switch port, trunk, allowed, VLAN, let's say 10 through 20, just for kicks and giggles. So we have that. Now that means that not all 300 or 600 VLANs are created, but potentially all propagating MAC addresses. What you're doing is you're limiting that down to these 10, and maybe there's 300 MACs learned between all 10 VLANs. That's a much easier number and much easier to scale. So then you could scale this out if you wanted to do that. Now in a situation like that, that's the direction I was going with them. About the time that we had sold them a block of billable hours, we had exhausted those billable hours. We're no longer working with that customer. They never reached out to us. We'd every now and then reach out and be like, hey, do you need any help? We'll provide you a little bit of insight here and there. Never responded to us. I have no idea where they went with that. I would hope that they took advantage of that. But that's why trunk allowed lists come into play. Again, it's not a security feature. It's an optimization of resources and stuff like that comes into play. But if you don't take this into consideration, there were switches with 1,500 MAC addresses on it, and when you would do a show MAC address count, which I believe I can do on these switches as well. Let me go ahead and try that out real quick. Go back to my mouse. Let me do a show MAC address count. Right here, it does it per VLAN, but I'd be okay with this. So this would be the total space, but this is an exaggerated number. You might say, well, that's a lot of MAC addresses. That's what, 7 million? No, 70 million. Let's see, 100,000, 10,000, 100,000, million. Yeah, that's 70 million MACs. Obviously, that's not a realistic number because of the fact that this is a virtual environment. I actually have a real switch. Here, let me go ahead and pull this guy up real quick. Let's do switch 2. These are 3750Xs. Go ahead and log in real quick. This is a 3750X show ver. 3750X. I do a show MAC address count. I can hold 6,000 MAC addresses. Now that's a pretty good number when you think about it, but in the grand scheme of things, that's still a lot of MACs. If we do a show VLAN, I'm not sure if there's a count. Yeah, I don't think so. I don't know what the upper limit is. Show VLAN brief. I have a lot of, I do a lot of testing and stuff like that. I don't know what the upper limit is for VLANs. I'd have to go to run some show commands. But the idea here is that we don't want to take into, we want to take into consideration what the total amount of MAC addresses are. Now you might say, well, 6,000, that's still a pretty big number. But then that's for that particular platform. If you have a bunch of lower end boxes, 36 or like a 2960 or something along those lines, those switches don't have the same size cam table. They don't have the resources to do that. As a matter of fact, I have another switch, is a 3750 V2, switch 1. Go ahead and log into that guy real quick. Show MAC address table count. This guy can hold 5960, right? So it's a little less than what the other one can hold. It's still a sizable number. But here's the thing. It's not so much how much an individual switch can support at this scale, or even at a scale smaller than this. It's how many, however many MAC addresses are stored on this switch are stored on all the switches in that VLAN, because they all have to know about it. Because they all have to know how to recurse to figure out, okay, what port do I use to reach that MAC address? How do I get there? Am I on that switch that the device is connected to? No, then I have to jump across the trunk link and there's some tagging involved. So your 2960s and stuff like that, if you have hundreds of VLANs with hundreds of MAC addresses, you're quickly going to exhaust a few thousand MAC addresses, a MAC address limit. And so how do you rectify that? Well, there's a few. There's the trunk allowed list. You can do more layer 3 segmentation. You can do per VLAN filtering. So there's a lot of things you can do, but then you start to add in complexity for the sake of scalability. So in that particular sense, is it worth it? That's a discussion you have to have. You know, what's a value you're willing to deal with? Some folks like to do VTP and only propagate what they need to down to the MAC address, down to the switches that they need. Some like to do trunk allowed lists. You could take pretty much every feature that Cisco has out there, and you can start overlaying that on top of your design to come out to the experience you're looking for. And that's up to you to determine. I can't make that decision for you. I can help you understand it. I can try to show some scale and stuff like that. But at the end of the day, that's something that you need to sit down and figure out and go, okay, what am I doing here? Am I going to be able to, does this make sense? And that's something that only you can determine. So that's why I bring that up and I give that example, because it's such a, in my opinion, it's such a applicable example to how this comes into play. So again, if we do a show MAC address table dynamic, I like the dynamic command because it allows me to show how many MAC addresses I've actually learned. So I can, the question is, can I still reach ASAV1? So if I click on AS server 2 and I bring this guy over and I do an IP config ping 172.16.30.1. Whoops. I can still ping my default gateway. And that's what matters, because I still have the ability of propagating the information between the endpoints. So if I come up here and hit the up arrow, I'm going to have the MAC address of the default gateway. And that's what matters. So that's why I bring up what I bring up, because it's applicable in that particular type of design. And if you don't understand the scale, that's where it can come into play. So that's really where this dials into and what you need to understand. Beyond that, guys, thanks so much for stopping by, and until next time, take it easy.